morning to all of you. Jai Hind to all of you. I am Dr. Gaurav Saxena, Associate Professor in EC Department. Today I discuss the Unit 1 important question paper which has to be asked in the university examination. So ST1 is to be going on in BEC 201. So I just discuss some numerical problems and some theoretical problem behind that. So first question is to be asked in Clipper circuit is what is the Clipper circuit? So what is the output of that particular system? So this is a input waveform, and this is the Clipper circuit. So we find the RL is 5 kilo ohm, 10 kilo ohm. So find the output voltage. So this is a Clipper circuit. So what is the meaning of Clipper circuit? Clipper circuit, those circuit which clip the input wave. So what is the meaning of Clipper circuit? This is two types. This is absolute clipping and the bias clipping. So this is a bias clipping example because we introduce a 4-volt battery across the diode. So this is a bias clipping circuit example. So this is a input waveform. So we draw a what is the output waveform if load resistance is 10 kilo ohm, if R is given. This is a ideal diode. So what is the output voltage? So in this case, first we see that. So this is a input voltage, and we draw a what is the output voltage. So how we calculate it in forward bias? You just see that this is a 4-volt. So that means if Vi lies from 0 to 4 volt, that means if your input voltage is to be lying from 0 to this voltage 4 volt, so this one is N and this one is P, this one is N, this one is P of the terminal of diode, this is the N terminal of diode. So what is the potential at Vp? Vp is this P type terminal is to be connected permanently by plus 4 volt, and this N is to be connected to the input of the supply. So that means Vn is to be introduced by Vi, or V at Vi lies from 0 to 4 volt. This Vp is greater than and equal to Vn because diode should be ideal one. That means and equal to Vn, this diode should be forward bias. So that means in this condition, diode D, this is a diode D, should be forward bias. So what is the meaning of forward bias? So that means this circuit is to be redrawn in the forward bias. We just see that. What is the meaning of forward bias? Forward bias, that means the short circuit. That means this diode should be short circuited. So what is the output voltage? So output voltage to be appear at the load end, which one is, we know that the output is same at parallel. So that means V of 1 2, V of 3 4, which is equal to V naught, which one is equal to 4 volt, because this 4 volt is to be appear at the output end. That means in that particular reason, when Vi lies from 0 to 4, the output voltage is plus 4 volt. So which is 4 volt constant from 0 to 4. And in that particular reason, diode should be D is equal to forward biased. And from 4 to 16 and 16 to 4, this Vn voltage is greater than 4 voltage. So Vp in this case less than Vn. So diode should be reverse bias. Because this diode should be ideal one, in reverse bias condition, diode should be open circuit. Because diode is reverse bias, because the diode should be ideal one, so we can say this is diode is reverse circuit, open circuit. So that means if this one is open circuit, so this one is open, so that means what is the output voltage? Output follow the directly input, because what is the input voltage which is directly to be connected to the output terminal, because this terminal is to be open circuited. So that means in particular reason they follow the inputs. So that means in that particular reason V naught is equal to Vi and diode should be reverse bias. But in this case, when Vi from 4 to 0, when Vi lies from 0 to 4 or 4 to 0, so this condition is to be repeated and diode should be forward bias and the output voltage should be 4 volt maintained. So this one is 4 volt. So in this case, diode should be forward bias. So V naught is equal to 4 volt. In this case, V naught is equal to 4 volt. So this same voltage to be appear. But in the case of reverse bias, we have to see that in this case, when Vi lies from 0 to minus 60 and minus 16 to 0, in this case, diode Vn always less than Vp, because Vn potential is in the negative potential. We have to be applied during the negative half cycle. We have to see that in negative half cycle, this terminal should be negative always, and Vp is to be connected to the plus 4 volt. So Vp always greater than Vn, that means diode should be forward biased. So the output voltage to be remain constant 4 volt in forward bias condition. That means in whole of the region, diode should be forward bias and the voltage should be 4 volt. So V naught is equal to 4 volt, because diode should be reverse bias, forward bias, because Vn potential always in whole of the cycle is to be less than voltage at P. This is P terminal, this is N terminal, voltage across N terminal is Vn, voltage across P terminal is Vp. So this question is easily calculate. This is the output of that particular clipper circuit. In that particular region, 0 to 4, diode should be forward bias, the output should be 4 volt. Then they follow the Vi, V naught is equal to Vi, because diode is reverse bias. But in this case, in the reverse bias condition, diode should be forward bias and they maintain the output voltage 4 volt. Another question is to be asked, because Zener diode. So what is the question is to be asked in Zener diode? In ST1, this supply voltage to be varied from 50 to 80 volt, because this is a line voltage regulation question, and the resistance is 5 kilo ohm. The resistance of input resistance is 5 kilo ohm, and the Zener voltage, if Zener diode is to be connected in the parallel of that particular input, and the Zener voltage is that particular diode is 50 volt, and the load resistance is to be connected. What is RL is equal to 10 kilo ohm. That means the load resistance is 10 kilo ohm. So they asked a question. This is a line regulation. So what is the meaning of Zener diode? Zener diode application in the regulation purpose. So they provide a fixed voltage at the output end. So this is a line regulation. So that means in the line regulation, they have to be change their input voltage from 50 volt to 80 volts. So what is so we maintain the output voltage 50 volt. So what are the Zener characteristics? Zener diode maximum voltage and minimum voltage we have to be introduced by selection in that particular Zener diode. So that means Zener diode are many specification in 50 volt. If I can say the Zener minimum Zener current is 1 milliampere to 10 milliampere, having a potential Vz is equal to 50 volt, and 10 milliampere to 20 milliampere, 20 milliampere to 50 milliampere. So what are the characteristics or what are the specification of Zener diode we have to be introduced, having a fix of IZ maximum and IZ minimum if the voltage input voltage vary from 50 to 80 volt and we maintain the output voltage 50 volt. So very good question which has been asked in the university exam as well as the ST exam. So how we solve this question? So first we calculate all the calculation by 50 volt. So such we introduce if the input voltage is 50 volt. So what is the Zener current? So that means how we calculate it. So if this one is 50 volt, sorry, this is a 80 volt, 80 volt to 120 volt. So answer this is a 80 volt to 120 volt. So first we introduce a 80 volt. So first we introduce a 80 volt. So if the input voltage to be varied from 80 volt to 120 volt, then what is the Zener current? Minimum Zener current we have to be calculate, and what is the maximum Zener current we have to be calculate for fixing the specification of that particular Zener diode having a load voltage 50 volt. So first we taking a 80 volt input. So 80 volt input is here. So this is a 50 volt. So the voltage across this resistance is to be, because the energy conservation law. So that means 80 minus 50 volt, which one is equal to the voltage across the 50 ohm resistance. So what is the, this one is 30 volt. So this potential is 30 volt. So how much current is to be flowing here? So easily we have to be calculated IR, because this one is current flow is IR. IR is the current which is flowing that particular resistance, which one is I is equal to V upon R. V upon R. R is to 5 kilo ohm. So that means 6 milliampere. So that means the IR is equal to 6 milliampere. Because the Zener voltage is sufficient to control this, so that means this voltage is to be appear at load end, because in parallel the Zener voltage is to be fixed. So that particular voltage VRL is to be fixed as equal to 50 volt. So that means how much load current is to be flowing. So we easily calculate the, so we easily calculate the, आप बोल दो कि वो सब. So we easily calculate the load current IL is equal to 50 upon 10 kilo ohm, which one is equal to the 5 milliampere. ठीक है, तो load current is equal to the 5 milliampere. So how much current is flowing in that particular region? That means, so IR is equal to the IL plus IZ So that means Iz is equal to 6 minus 5 is equal to 1 milliampere. So Iz is equal to 1 milliampere. ठीक है? So this zener current minimum is 1 milliampere, and the Iz max. What is the Iz max? We have to introduce the 120 volt. So 120 volt is to be fixed here. So what is the current? 120 minus 50, that means this one is 70 volt. So what is the current in resistance R, which one is 70 upon 5 kilo ohm? That means 14 milliampere. 14 milliampere. That means load current is to be fixed 5 milliampere. So Iz max is equal to 14 minus 5, 9 milliampere. So we introduce a 9 milliampere and 1 milliampere zener current specification if your voltage to be varied from 80 to 120. Thank you.